Assalamu alaikum wa rahmatullahi wa barakatuh, dear students. In our today's sessions, we have discussion on probability rules, which are very much important for better comprehension and understanding of probability to learn the rules of probability. So, in our sessions, we have a couple of rules related to probability. Inshallah, I'm just trying to explain them in very much simple and easy way possible. So the first rule in probability is very simple but very important, and it tells us that the probability of any event, let's say event A, must be between 0 and 1. It cannot go below 0 and cannot be above 1. Okay, what does that actually mean? If I say the probability of something is 0, it means that it's impossible. There is no chance it will happen at all. Or if I say the probability of something is 1, it means it is very much probable. You can say it's guaranteed to happen because 1 is indicating 100%. So, getting heads on a fair coin. In this example, if you flip a fair coin, there are two equal probabilities or equal outcomes you may have, either getting heads or getting tails. So the probability of getting head is 0.5 and the probability of getting tail is 0.5. Now this probability is valid probability because it is in the range of 0 and 1. So dear students, in rule number 1 you have learned that the probability of any event must not be negative or a value which is greater than 1. Okay, second, we have the probability of S equals 1. This means the probability of sample space, which is representing all possible events, right, that must equals 1. For example, if you flip a coin, there are two possible events you have. Either you have heads or tails, and the probability of heads is 0.5 and tails is 0.5. When you add them together, their total probability must not be more than 1. So that is what we mean by the probability of S, or you can say the probability of sample space that equals 1. Okay, if you roll two dice, there are 36 events. Inshallah, I'll work on this example. So all of these possible events, when you sum their probabilities together, then the total is not greater than 1. So that is what we mean that the probability of sample space must equal 1, means all probabilities when they summed or when they are added together, their total summation is not more than 1. Okay, next we have complement rule, dear students. And complement rules, we say the probability of not getting A is equal to 1 minus probability of A. When you are interested to know what is the probability of not getting A, for that you must have first the probability of A. So we have total probability of 1, which is representing 100%. So from this you should subtract the non-probability, the event of the non-probability, then that is giving you the opposite of the probability of A, which we call it the probability of not getting A. Okay, very much simple. If there is a non-probability of any event, you should subtract it from the total probability. That will give you the probability of the opposite, right? Or here the probability of not getting A. The A bar is representing the probability of not getting A. So you can also state that the probability of not A equals to 1 minus probability of A. Okay, next, dear students, we have addition rules for mutually exclusive events. First, you need to know what are mutually exclusive events. Mutually exclusive events are those events which cannot happen together and cannot happen at the same time. For example, we have two events here. Event A, drawing a king, right, which is a card, right, in a set of standard deck of 52 card. The probability of king is 4 over 52. Why? Because king is 4 times in total number, and also the queen is 4 times in total number. So if you are interested to draw the probability of king, right, then you should divide 4 over 52. That is giving you only the probability of king, and for 4 over 52 is also giving the probability of queen. But keep in mind, dear students, both of these probabilities are mutually exclusive. Why? Because they cannot happen together. In one time, you can only draw one probability. So the question here is that what if you just try to find out the probability of at least one? You are interested to know what is the probability of at least drawing either king or queen. So that is why we have this rule, the probability of at least getting A or B. You should add the probability of A and the probability of B. So the probability of A is 4 over 52, and then the B is queen, which is 4 over 52. When you add them together, that is giving you the total probability, which is 0.15, and that's 15%. So what is the interpretation of 15%? You can say the probability of at least getting either king or queen, that is 15%. Okay, dear students, this was addition rules for mutually exclusive events. Now we have general addition rules. In general addition rules, we again have two events, but they are not mutually exclusive. It means they can happen together, okay? So if you have two events which are not mutually exclusive and they can overlap, then what is the probability? You have to find their probability. Very much simple, just check the probability of A and add it with the probability of B and minus the share part or the overlap from those probability, that will give you the probability of A or B in case of general addition rules, okay? Okay, this example can be more clear through the following examples. Here, look, 40% of customer bought tea, right? So their probability is 0.4, and 30% of the total customer bought coffee, so their probability is 0.3. Now there are 10% of the customer who bought both tea and coffee, and their probability is 0.1. So you can say among 70% customer, there are those who have purchased both tea and coffee. So now, if you are interested to know what is the probability of customer who purchase either tea or coffee, right, just to find out the probability of one of them, right, then you should add both probabilities and then you should subtract the share part. This is the share part, right? This is the overlapping part. Then the overlapping probability of A and B means the customers, those who bought tea and coffee, their probability is 0.1. Now you should add these two probabilities and subtract the share part from, then that is giving you the probability of either A or B in case where they are not mutually exclusive, dear students, okay? Okay, next, dear students, we have conditional probability. And conditional probability, first just you need to know the interpretation of the conditional probability. When we have probability of A or B, okay, what does this really mean? This mean what is the chances of getting A given B? In other words, you can say that when B already happened, what is the probability of A in that situation? Okay, if you just try to know this situation, then you have to add the probability of A and B, and then you have to divide it by the probability of B, but provided that the B should be greater than 0. This is very much important. Okay, for clarification, we have in examples. Okay, you run online store. 30% of all customer buy product B and 20% of all customer buy both product A and B. Okay, here is a question. I just try to figure out all those individuals who already bought product B, what is their chances that they will also purchase product A? Okay, so this is what is called conditional probability. Once again, I'm just repeating. I'm just trying to find out what is the probability of those individuals who already have product B, they have the chance to buy product A. So for this kind of probability, we must have the percentage of the customer who already have both product. Okay, keep in mind, once again, I'm just repeating this. If you just try to find out the conditional probability, the probability of A given B, then there should be the number of customers or the percentage of both event, right? And if there is no percentage of both event, then you cannot find out the conditional probability. So in our example, we say, what is the probability of those individuals who already have B, right? What is their chances that they also purchase or buy product A? Okay, in these situations, just you have to the product you have to find out the probability of A and B. So what is the probability of A and B? This is 20%, and you should divide it by the probability of B, which is 30%, and that will give you the probability of A given B. Inshallah, don't worry, I'm explaining this in more detail in class. Okay, next we have independent events. What are the independent events? Independent events are those events which are not affecting each other. If, for example, we have two events, one is A and B, and they are not affecting each other, right? They are not related. We call them independent events. So keep in mind. So in independent events are those events which are not affecting each other. So in our example, you can say the probability of A given B, that is considered independent if that equals to probability of A. It means the probability of B is not affecting the probability of A. So that is why we say the probability of A given B, that equals to probability of A. So at your coffee shop event we have two events. One is event A, customer buys a coffee has probability of 0.7, and their customer, and also we have a customer uses a free Wi-Fi. Both of these are independent. Why? Because a customer buy coffee has nothing to do with a customer uses Wi-Fi, right? So customer, you can say that is the same customer. If a customer is buying coffee, that is nothing to do, right, with that customer may or may not use the free Wi-Fi. So we can say the customer who buy coffee is probability 0.7, and the probability of customer who is using the same customer who is using Wi-Fi 0.7. Now these are independent events. Now if you just try to find out the probability of independent events, what is their probability? Very much simply, we have this rule. So the probability of independent events A and B, they are independent, but what if they happen together? Simply just multiply the probability of A with the probability of B. That is giving you the probability of independent events. Once again, this is just for explanation purpose. You can say the probability of A over B is uh, independent. You can say A and B are only independent if the probability A given B is equal to probability of A, and that is 0.7. Okay, finally, dear student, we have dependent events. If there are two dependent events and they are depending on each other, like probability of A and B, and they are dependent on each other, then you should take the probability of A multiplied by the probability of B given A. Okay, first you should find out this portion, and then you should multiply it with probability of A. So you run an e-commerce website and track customer behavior, and there are 1,000 customers. Among there, 300 people bought product A, and out of 300, there are 210 also bought product B, dear students. Now, 210 are those students who already bought both of the product. But now we are interested just to know that what if both of them, customer A and B, what is the probability that both of the customer they buy product A and product B? For this, now you should find out the dependent probability, and then you should find out the probability of A. So the dependent probability is probability of B given A. So we have probability A plus B over probability A, and that's equal to 120 over 300, 0.7. Now when this is clear, then the probability of A is already there, and the probability of A should be multiplied within this dependent probability. That is giving you the probability 0.21. So the conclusion here, dear student, you can say that the probability of A and B, when they are dependent on each other, then simply just take the probability of A multiplied to probability of B given A. This is the rule, okay? Don't worry about it. This is simple rules. And when you add them together, multiply them together, this will give you 0.21. And you can say there is 20%, 21% chance that the probability of A and B, when they are dependent on each other, they may purchase both product. Okay, hopefully this is clear. I just explained very much fast, but don't worry, inshallah, I'll explain it in class for you.